Welcome to Math Recompression. This is Unit 16. Now, Unit 16 was split into the first half, which was those first 4 days. And that ended with a tangent, and then we took a test. This is the start of the second half of Unit 16. So you will see on all these note sheets says Unit 16, Part 2. So this is the second half, and this is the first day of it. So trigonometries, or right triangle trigonometry, is going to come back to it. So remember, this is SOHCAHTOA. And we'll walk through these. Remember, S is for sine, opposite, and hypotenuse. Cosine is for, C is for cosine with adjacent and hypotenuse. And tangent is for opposite over adjacent. So if we're making our fractions, and here we have the sine of C, cosine C, tangent C, I'm focusing on angle C. So that's why I'm circling it, because my reference is to make these fractions, I'm all doing it in terms of angle C. So based on angle C, going across 24 is my opposite. The hypotenuse, since I have the 3 numbers, the hypotenuse is always the biggest. And it's, again, across from the right angle, and A is adjacent. So sine is the fraction of the opposite versus the hypotenuse. So 24 over 40. Cosine is the adjacent over hypotenuse, which is 32 over 40. And then tangent is the relationship of opposite versus adjacent. And it's all based on angle C. So opposite of 24 versus 32. Now the directions do say reduce as much as possible. So I do want to reduce. This is 3/5, 4/5, and what do we have? 3/4 here. So if you feel comfortable with that, go over to number 2, pause the video, double check here. I have a new triangle set up. Z is the reference. So I have opposite, hypotenuse, and adjacent. Sine is O over H. Cosine is A over H. Tangent is O over A. And those are not reducible. So we're good. Now the next part is making equations with these using our calculator. Depending on your calculator, I need to double check to make sure mine is in degree mode. So I'm going to hit the mode button here. And I'm looking for to make sure degree is highlighted. It has the black surrounding. What does it look like if it's not? This is radian. Radian is a different measure in terms of pi. And it will definitely give us different answers. So if that is highlighted over here, you just arrow up or down to get to degree. Make sure it's blinking on it. Hit the enter button and it should highlight over to there. Now once you're done, you should be able to hit clear and you get back to what's referred to as a home screen. All right, so I'm going to hold on to that for a sec. Now this 75 is awkwardly sitting there, but that 75 is for this angle here. Okay, my whole angle that I'm working with is 75. Opposite is here, adjacent is here. Hypotenuse is blank. If the side's blank, it's not going to be helpful to us, so I'm going to ignore it. So I have the O and the A to work with. And I use tangent because tangent uses the O and the A side. So I'm going to do tangent of my angle, so 75, equals, now I put the opposite over the adjacent. I'm going to put tangent of 75 over 1. I'm going to do some cross multiplying. I'm keeping that tangent 75 together. It stays together, so I'm not just going to separate it, just do tangent. Tangent needs something with it. So I'm going to divide both sides here by tan 75. Excuse me. And now this is where I go to the calculator. I have 38 divided by tan 75. So I go to this, I type it all in. So 38 divided by tan 75. I do it all at once. Hit enter. You can close parentheses if you want. Sorry, let's get there. We'll round to the 10th, so 10.2. Oh, sorry, just kidding. Haha. It says nearest hundredth, so let's do 10.18, 10.182, so 10.18. All right. Now, if you feel like decently okay, start setting up the next one. Pause the video. Jump back in a second. 47 here. Opposite is blank. Hypotenuse and adjacent. I am ignoring the opposite side because there's nothing there. There's no label, no X, no number. So I'm going to ignore it. So I know I'm going to have the A and the H to work with. So I jump to cosine. So I write cos, my degree, my circled number. Adjacent over hypotenuse. Set this up, cross multiply. Get those. Divide by cos 47. Calculator work. All right, you don't have to clear it, but you can. 29 divided by cos 47. And to the 100th, we got 42.522. So this 2 makes the 2 stay. It's not closer. It's closer to 52 than 53. So I got 42.52, which is good because a hypotenuse should always be bigger than the other sides. And if 29 is my only side, at least I have a number bigger than this. So we're on the right track. All right, number 5 here. I'm trying to figure out the angle measures, and this says use inverse trig. No, I know we didn't do it yesterday, but use inverse trig. All right, so it doesn't matter which one I do first. I have angle X though. I get opposite, hypotenuse, adjacent. Hypotenuse is blank, so not helpful. So I'm going to use the opposite and the adjacent. So opposite and adjacent is tangent. So I have tangent of whatever I circled. So tangent of angle X equals 32 over 24. Now this is the inverse trig. To get the X by itself, I have to separate these, and I can't just divide by tangent. I have to do what's called inverse tangent, or tan -1. And we know whatever we do the left side, we do the right. So I'm doing inverse tan -1. Inverse means reverse it. Tan -1, 32 divided by 24. Okay, so. So inverse tan is, or if you had sine or cos, they are right there for you already. So with the -1s. But to get them, I have to press the blue button first. So anything in blue, you have to press the blue button. And I'll make that change to an arrow there. So second and then tangent. So it should put it however you wanted to look. It looks like tan -1. It should look like that on there. And I just type in the fraction. You don't have to do anything else. Just do top divided by bottom. 32 divided by 24. There we go. 53.13. And that's in degrees because we're doing degree measure. Now, we can set up trig from angle Z to do that, but all triangles have to add up to 180. So if you have one triangle is 90, a second angle, sorry, one angle is 90, a second angle is 53.13. I can just combine these and subtract them from 180. Whoopsie. There we go. All right, so I have 180 minus the 90 minus 53.13. It's just different ways. We could do inverse trig again. That's not a problem, and you should still end up with the same thing. So if you feel like you're comfortable, go ahead over to these. Pause the video. Now on these, you have 3 numbers to work with. So how do you pick which one? It doesn't matter. You pick which one you want to work with. I haven't done sine yet on any of these, so I'm going to do sine. So I have sine of angle A is 35 over 37. Because they're all focused on or referencing the same angles from the same angle, whether I do sine, cosine, or tangent, I should get the same value. Inverse sine. So what I'm going to be typing into my calculator is sine -1 and 35 over 37. Now if you did cosine, you do cosine -1, so inverse cosine. If you did, and the numbers should be different. Right, there we go. Oop. 71.0, so that's a 5, so that's going to make the 7 is closer to 0.08. So A is 71.08. I have 2 angles. I'm going to subtract them. So 180 minus 90 minus 71.08. I get about 18.92 degrees. And there's an extra 5 there for whatever reason. Typo. All right, on the next one down here, it says find all the missing parts. So has a little bit of SOHCAHTOA in it, has Pythagorean theorem in it. If you think you're good, go ahead and pause it. I'm just going to work through it. Let's see, x squared plus 10 squared equals 15 squared, 100. All right, I'm getting the missing side. It doesn't matter the order you do these though. And I got, let's see, round the lengths to the nearest hundredth. So 2 decimals, so 11.18 for this side. And I'm going to go with angle Q first, opposite adjacent hypotenuse. I'm going to go with my O and my H side since they were already there, just in case I messed up my adjacent side. In case I mess it up and then I use it in another calculation, it's going to continue to be off a little bit. So I'm just going to use the 10 and the 15 because they are already there. I have sine Q, 10 over 15. So I move this over by doing the inverse. Inverse sine 10 divided by 15. So 41.81. And 180 minus both of those 2 angles. Minus 90 minus 41.81. I get 48.19 for angle R. So now on the next page, we start talking about altitudes, and you're going to see 2-dimensional shapes showing up. Altitudes are known as heights. Altitude is the fancy word for a height of something. It's the official word. If you go to the doctor and get measured for how tall you are, they do, you know, when you have your physicals, stand up against the wall, they measure that straight up and down. So height of anything measured, and a lot of times right away we think if you've flown anywhere, they say we're at a cruising altitude of however many thousands of feet. And that's the straight line to the ground, height off the ground that the plane is actually at. So height of anything measured straight, measured from a vertical to a right angle on the ground. We'll just say on the bottom because maybe it's not necessarily on the ground, right? So an altitude means height. Everything measured from a vertical to a right angle on the bottom. Now, theoretically, the word bottom is a little specific, and it doesn't have to be the bottom, because something like this, an altitude can be here. But if I had spun this picture and said, oh, there's a right angle here, so there's a height, but I can spin this picture and it can be up in the air, it can be on the left, it can be on the right. So this could be an altitude, or this could be an altitude, depending on which one, how you are looking at it. So altitudes can be sides of the shape. If this could be an altitude going straight up, but if I had it spun, that one could be an altitude. Now, when you see this middle triangle, if they were to draw a height, they might drop it straight from this vertex here and make the right angle there. So altitudes can sit inside the shape. They could go from a corner to an opposite side. I don't want to get too crazy and make these pictures look super. Now this one, if I were to draw let me get a pencil here. If I were to draw an altitude, or try to, I could draw one going here. So I could draw it from the bottom one and go up to the top, and that could be one of my altitudes. And that's fine. If I wanted to go from another corner, I'd bring it over and say, well, that's not a right angle. There's no way to make a right angle with some of these. So sometimes you will see some of these with dashed lines, meaning I'm going to make a right angle, but my location of my right angle has to be sitting outside the shape, outside the triangle. So occasionally when this happens, this is the actual altitude. Even if it's not connecting to the shape on the inside of it, an altitude or the height of the object can be the outside. So it's stretching over, it's so far over that you can't see it directly inside the shape. Now this is going to come into play, and you might see words like height instead, and they mean the same thing. If you see the word altitude, automatically that means height. We're going to switch to area. So area is how many square units so whatever the unit is to the second power, something covers. And you've been doing these since you had the grid ones where you have to count the boxes off. You have how many units when they put any kind of flooring down, square, how much carpeting something's going to cover. If you're painting a wall, you're covering the square units because you're covering the wall with paint. And here are some different formulas. Some may be familiar, more familiar to you. So this first one, A, So area, so A is always for area. A equals B1 plus B2 over 2 times the height, which is your altitude here. This is for a trapezoid. A equals pi r squared is for a circle. Base times height divided by 2, that is for every triangle. A equals base times height is for a rectangle. Square, because you have the same base and height, they're just the same, or parallelogram. And this is a particular one. You don't have to use it, but you can. This is the very specific one just for a square. Since the square has all sides the same, you can raise it to a second power, or you can just do, if it was 6, you could do 6 to the second, or you could just do 6 times 6 for this one. You pick which one you like better. Okay, so knowing what shape you have, knowing the formula to pick out, you're a number 8. So this is a rectangle. So area is base times height. It doesn't matter which one's which, because if I switch them, if I do 4 times 9, or if I switched and did 9 times 4, either way, you get the same answer, 36 centimeters squared. Now we write the label as squared because what we have is 4 centimeters times 9 centimeters. So if we have 4 times 9 and centimeters times centimeters, it's 36 for the numbers, and then centimeters is to the second power because we're multiplying 2 dimensions with that. So units are not the focus, but be aware, try to get them on there as much as possible. Area is always to the second power. Okay, stuff like this are regular shapes. They're going to have pieces of information there, pieces missing. These are congruent. You can split it up, you can add to it and subtract it out, you pick. So if I add to it, like complete a rectangle, what is this, 10 and 10, so this is 20 up and down. So the whole outer shape is 20 times 20. And I want to take out this rectangle here, so I have 7 up here, and this is 13. So I want to minus 10 times 13. So I want to subtract 130. Now if you added the other way, so if you broke it up and added the pieces, you should still get the same thing. Oopsie. That's 270 inches squared. So if you broke it up into rectangles, you should still get the same thing. This is a parallelogram. I need a base times height. Now there's other random numbers in there, so I never use the slant. It's always the base, the straight up and down altitude here, which is your height. So 10 times 6, which is 60. All right, the next one is a triangle. Again, you have extra information there. Too much numbers. I know not all of them are connecting there, but there is that height here. This is your height, the altitude here, sitting outside. It is connecting here now. I know it's this dashed line, but it is connecting to this, which is your base. So the slant is no good for you. Now, the biggest thing with the triangle formula, I've seen people do a lot. You're used to doing base times height, but don't forget it's not a full base and height. We're missing part of the shape here. We need to divide that by 2. So 16 times 16 divided by 2. 128 meters squared. Some of these you will need to work backwards. They tell you the shape. Rectangle, base times height. I'm getting that down before I do anything. The area is 98. The height is 7. B times 7. So once I have my numbers in, work backwards. 98 divided by 7, 14. I apologize. Whew, runny nose. Again, I have a rectangle here, determine a base here. Oh, that's the same question. We're going to ignore that one. Let's give that one. Should get the same answer. Number 13, find the height of a trapezoid. Okay. Total bases total. So this is both bases add up to 25. Now the parentheses are there for a reason. Now my area is 200. So what do we have? 200 equals 25 over 2 times your height. 200 equals 12.5 times the height. Divide out. Get the height at 16. Okay, again, you're told what shape, a triangle. $143 for the area. Base, I don't know. It's okay to divide those first. So 11 and 2. 5.5 B. And I do get an answer of 26. Now, a lot of these are coming out without decimals. Do not worry if they are decimals, so they will have an area. All right, the shaded region. So I have the triangle and the square. So I have to do two things. So there's base times height over 2. And then I have the square, which is base times height. All right, my triangle, I got 10 times 14 over 2. I got 70 for if I had the entire triangle, it'd be 70. But I took out this piece, so I'd need to take that out of my problem here. So it's taken out of the whole thing, so I end up with 45 feet squared. On the next page, it talks about for each circle, determine the area with a diameter of 18. All right, so if the diameter is 18, if I just split it in half, I get my radius. All right, so area. Area is pi r squared. My radius is plugged in. I get pi times 9 squared. So exact means I do as much as I can, but do not make a decimal, which means leave pi alone. So this is 81 pi. Absolutely fine to leave it like this. Preference is to leave it like that. Anytime we cut off decimals, we're changing numbers. So, exact means leave it alone. However, if I type in 81 pi, so 81 and then second button and then the caret key over here, we'll put pi in there. This will give me a decimal answer about, what do we got here? Nearest tenth. So 254.5. And what do we got? Centimeters. Say exact means leave any roots alone, square roots alone, leave any pi alone. Approximate means you have the numbers in there with a decimal. All right, so when you start seeing some of these with more going on, there's more complicated parts to them. I don't have a height here. You could do the trapezoid here, or you can do the triangle and the rectangle here. It doesn't matter the total how you get there. But the problem is I do need this height. This is my height of the triangle. It is also the height of the rectangle. You have 2 3 sides here for the triangle, so I would go to Pythagorean theorem. X squared plus 9 equals 25. Subtract. X squared is equals 16. Now, if you want to do the triangle, do base times height divided by 2. You can get that triangle part and move the 6 over, or just do 6 times 4 and then combine your totals. If you want to do the trapezoid, you would take the 2 bases are the 2 sides that are parallel to each other. So one is 6, the other is 9, divided by 2 times your height of 4. You should get the same answers if you do the triangle plus the rectangle of 30 inches squared. Now in this one, 18, I'm going to move this 22 up here. Or you can move the 15 ultra interior to there. Again, you don't have a height here. And the reason I'm moving these numbers around is so I can do SOHCAHTOA. O, H, and A. I have O and A, so I'm going to do tan 15 equals X over 22. I'm going to cross multiply 22 times tangent of 15. I'm going to type it in, 22 times tangent of 15. I get that that side is about 5.9. And so when I do the area of the rectangle, I'm going to do base of 22 times height of 5.9. And we get about 129.8 centimeters squared. Okay, so variety of things. Again, number 19, I have Pythagorean theorem to do, so I can figure out the height. Again, number 20, you're going to do SOHCAHTOA here to figure out the height. These are in the notes. Feel free to do them and check your work. Otherwise, let me know if you have questions.